Hello there. It's Chem Coach Powers, and I have got a great little logic tree for you guys to follow to help you understand how to name chemicals. It's pretty easy. We call this chemical nomenclature, and nomen just basically means name, and clature is basically a way of saying name. So this is chemical name naming. So it's an easy process. Basically, you're going to follow two different paths, and then we'll come back across on one path after we follow the first path. So, all right. So what we have here is the first question we have to ask when we are naming a compound that we see. So if you're given a chemical formula, you've got to ask this first name. All right. And the first question you ask is the bond ionic or covalent? So we're going to go ahead and follow along and we're going to take the covalent path at this point. Okay. So we're going to say, all right, we're going to say it's covalent and we're going to follow that path. And so what we see, remember, a covalent compound is something that has a non-metal combination. So we're looking at two nonmetals, something has an electronegativity difference of less than 1.7. Well, this is easy. Anytime we have covalent compounds, we are going to use the Greek prefix system to name things. What's the Greek prefix system, you ask? Well, there it is. You just need to know that these different symbols, these different prefixes, are associated with these different numbers. So mono is one, di is tri, et cetera, et cetera, et cetera. Some of the things that are different than probably the Latin prefix system are things like your hexa versus hepta. Sometimes those are confused a little bit with what we have in Latin, but we're using the Greek prefix system. For instance, Latin's four is quad, and here we have in the Greek prefix system we have tetra. And in the 7 for Latin, it's septa, and we have hepta. So make sure you're clear on the difference there. So we just have to memorize those issues there. Then we're going to go on and we are going to look and we're going to see that the rule is pretty easy. The first element gets its name. Okay, these are binary compounds that we're dealing with. And then the second element is going to end in an IDE ending. Okay, other things we can remember is that we don't have to use the word mono or the prefix mono on the first element. And if we have a double vowel combination, it's okay to go ahead and drop that double vowel. We don't need to say monoxide or something like that. We can just say monoxide. And sometimes it takes a little bit of practice getting used to where you might drop the end of the elements. Some of them are a little bit goofy. Nitride is what you would say. You don't say nitrogide, even though you're dropping a little bit more than just the last syllable to make that work. Oxide instead of oxygide. So sometimes you're actually dropping a little bit more. Okay, so we have a compound like CO, and that would be carbon. We name the first one carbon, and then the second one, we put a prefix in it, mono, and then we give it the IDE ending, monoxide. Okay, so oxygen, monoxide. There you go. All right, well, pretty easy there. And we have that solution. And now, what would we do if we were going to name something that was an ionic compound? Let's take us back out to the beginning. All right, so now it's not a non-metal combination. It's a non-metal combination. Okay, well, let's do the ionic dance. The bond is ionic. It's a metal non-metal combination. Now, the first question we have to ask once we've decided it's a metal non-metal combination is, does the cation carry more than one charge? What I mean by that is, does iron, for instance, is that the element you're dealing with where iron can have a 2+ or a 3+ charge, or copper, it can have a 1+ or a 2+ charge? Those things are carrying more than one charge. So we're going to say no for right now. We're going to say this is like an alkali metal or an alkali earth metal, just has a single charge. Way to go. That's going to make it super easy. Cation is going to get its name, okay? And the anion ends in IDE. Remember, the cation is a positively charged ion and the anion is a negatively charged ion. We just drop the ending and end it in IDE. So if we start with K2O, we would say the first element, K, is potassium and O is oxygen, right? And so we have to drop the ending and we just say IDE, oxide. All right, that was easy. Now, let's go ahead and assume now that we have a compound where the cation has more than one charge. And if that's the case, then we have to add a stock system of naming, okay? So this is like a 2 plus or a 3 plus. It can have more than one charge as a particular element. Now we're just going to go to the left side of this little bracket. Yes, it has more than one charge. So we use the stock system to name this bad boy. First thing we've got to do is figure out what the charge on the cation is. In order to do that, we have to look at the anions. What charge haveth the anions? Well, the anions, let's go ahead and look at an example to figure this out. If we look at this one, we've got chlorine as an anion, right? But there's two of them. And so when we take that as our hint, we know that chlorine has a -1 charge, but because there's two of them, we know that the total charge is -2. So iron in this case is going to have a +2 charge in order to balance out. Remember, these compounds are all neutral compounds, and so they balance out. So if I have -2, I've got to have +2. So my iron would have a +2. And so what would I call it? I would call it iron 2. Now, there are some other ways to address this. You can also talk about it in terms of ferrous instead of iron 2. Each of these different compounds will have a different name that doesn't deal with the stock system Roman numerals. Now let's look at this one. We have chlorine, but there's three of them this time instead of two. So that tells me, well, each chlorine's -1 times 3 is -3. So in this case, our iron has to have a +3 charge in order to make that all balance out. So this is iron 3. Again, notice how I use parentheses around my Roman numerals here to designate what iron this is. All right, so now we're going to choose the appropriate cation charge to balance it and use a parentheses name to start the name and finish the name with an IDE anion. So what in the world am I talking about there? All right, so we have our FeCl2. Well, we simply say iron, and then in parentheses, we put the Roman numeral 2, because that's the charge of iron. And then we end in IDE with our anion. So it's chlorine, but with an IDE ending, so it's chloride. If we did FeCl3, well, that's iron 3. We start that way, and then we end it in chloride the same way. Okay, so now you are a master nomenclaturer and you are ready for more. You can do this with any type of element, and it's super easy. So I think you're going to have fun naming compounds now. Remember, the reason that it's fun to name compounds is because it's just fun. All right. Thanks a bunch. I hope you have a great time naming compounds.